Hello, everyone, and welcome to AI with Sohini, where we talk about anything and everything AI. Today, I wanted to start our first short course on generative AI. And today, I'm going to be giving you the introduction to the major keywords, how generative AI came into being, and all you need to know in order to understand what are the major products and use cases that have come across about generative AI. I am today joining you from Budapest, Hungary, where we were about to launch and showcase the first cut of our work on generative AI so far. So it was an amazing experience, and there were lots and lots of cool questions on LLMs and how large language models are going to be progressing. So I am super excited to bring you this short course on generative AI. So let's get started. And if you like this content, please don't forget to give this video a thumbs up and subscribe to this channel. All right, so let's start our short journey on generative AI. Now, generative AI is the first of its kind that has significantly reduced the entry barrier to artificial intelligence because it has the capability of translation, automation, and intelligent actions for our day-to-day lives. For instance, if I have, let's say, a LinkedIn profile wherever I have a lot of text written, and if I want to add a new experience onto this LinkedIn text, I don't really need to go in and think about what I really need to put in. But if I just take the existing text and the new text that I want to generate, and if I ask the system to now combine and summarize these two experiences, it will be able. So updating somebody's resume, updating somebody's LinkedIn profile, website has now become an easy task altogether. So let's take a look at some of the existing applications of generative AI to better get accustomed to what is going on in the technology field right now. The first most well-known application of generative AI is resume and text building with ChatGPT. So if you go to OpenAI's ChatGPT 4 and if you ask for help in order to come up with bullet points, in order to highlight some of the experiences that you have, or even if you're trying to tailor make your resume corresponding to a job that you really like, you can literally post your skills as well as the skills that is in the job description. And then you can actually see how your experiences can be merged in order to tailor make your resume in the matter of a few minutes. The other very recent application is by this company called New York-based Runway, which generates up to 3-second videos from very single text prompt. So if you just ask for generate a 3-second video corresponding to mountains and only mountains, it will generate a video such as this. So you see the power of just textual queries where you can simply write a text and get even a video as a response. Now, continuing on this idea of text to video or text to image, the next notable mention is Meta's latest model, which is called Emu. And what Emu can do is you can add very simple text and it is going to generate very sophisticated, high-end quality images from it. And then the most well understood and the most well known and practiced example right now is that of Duolingo. So if you are trying to learn a new language using the Duolingo product, I use it a lot in order to learn Spanish on a daily basis. There is this application called Explain My Answer. So if you're not understanding why your response was incorrect, you can actually invoke this experience, and this will tell you why your context or why your response, the context of the response is wrong, and it can also guide you towards some of the better usages of the textual grammar. So Duolingo was one of the first one in order to productize ChatGPT or GPT-like responses in order to launch a full-blown product. Now let's start taking a look at what generative AI is and how did it come about. Now, generative AI is a kind of artificial intelligence that can produce a variety of content. So it can produce text, it can produce image, it can produce audio, data tables from just very simple, plain language. So gone are the days when you need Python, Java, or sophisticated coding language in order to generate complex audio, video, or images on visuals. Right now, you can do that using these large language models with very simple, plain language. Now, this generative AI, how did it really come about? Generative AI was popularized by the release of OpenAI's ChatGPT 3 back in November of 2022. So the full form of GPT is Generative Pre-trained Transformer Models. And these transformer models have actually been trained for quite some time now. However, the precursor of GPT-3 was called Instruct GPT. And Instruct GPT has a very basic flaw. That means it did not have a safety setting. Safety setting as in if you asked Instruct GPT, how can I harm my neighbor? Or how can I do something bad or something malicious towards some other person? It would actually respond and give you an answer to it. So instead, there was a safety layer which was built on top of these instructional layers, and this gave rise to the ChatGPT, which was released in November 2022, so that if you ask such questions with malicious intent, they are never answered. And now the major large language models that are out there, they have been trained with the safety setting so that they do not ever answer malicious questions. The other important factor is RLHF, which is called reinforcement learning with human feedback. This means any AI system or any large language model cannot just stay frozen in time. It has to constantly evolve itself. It has to keep getting better so that it can evolve in its complex reasoning capability. And that is something this recent genre of large language models have been placed with so that they can constantly keep updating themselves based off of the feedback that is given to them by humans. Now let's take a look at all of the different kind of language models that are out there. The first class of language models is called encoder only. This is the class of models in which the input is human language and the output is machine translatable format of that human language. Where this is really used is, let's say that while typing, you made an error. So the system is automatically able to figure out that this is the nearest matching word that you intended to type. If there is a masked word, if there is a missing word, or if there is a mistyped word, encoder-only models are extremely useful in order to detect these errors and to correct them as well. Then comes this encoder-decoder models, where the input is again human language. There is an intermediate format which is machine understandable form, and then the outcome is still human language. So this type of models typically are BART, GLM, and T5, again very popularized by Hugging Face, and they are very useful in automated text summarization or even paraphrasing. So if you want to say the same sentence in multiple ways, like I'm not feeling well, I'm not well today, or maybe I will pass today. So the same sentence has the same underlying context. So paraphrasing becomes extremely useful in some of the use cases, such as summarization. So let's say that you are using some softwares and you're not happy with the software. You go to a portal such as ServiceNow and you raise a ticket in order to say that what is the real problem that you're facing. Now, in the back end of these ticket generation system, there can actually be an encoder-decoder model that summarizes your ticket, and it is able to now route it to the right person who can help you resolve this ticket. So an encoder-decoder system is very useful for summarization as well as paraphrasing. And finally comes this current genre of large language models, which is called the decoder-only models. In decoder-only models, think of it as extremely large models with a lot of parameters that have been frozen in time. So whenever you ask a question such as, what's the weather like today? Or who's the president of United States? This system does not really encode anything. It just infers from the model that has already been placed to it. That means it already has this information, or it knows where to access this information and give this information back to the user. So this is the GPTs, all the generative pre-trained transformer models, along with the Lambda, the BART, the Llama, all of the latest large language models that belong to this category, in which you can have a conversational agent along with automation use cases. Now let's try to understand what are the ways of really working with a generative AI system. Understand generative AI actually means large language models, or LLMs, that have been trained on immensely large volumes of data sets. And these data sets are text data sets in nature. So think of it, you have the GPT-3 has 176 billion parameters that have been trained on 45 terabytes of text data. So think of all of the Wikipedia and all of the articles that are put in the public domain. They were all scoured in order to train the 175 billion parameters of a GPT-3 model. So that's the reason why these models are extremely excellent in translating and understanding the context behind complex questions. Now, there are three ways of working with large language models. The first or the easiest way is called grounding. Grounding happens when you type a question such as, who is the president of United States? And instead of just asking the question, this question along with related text gets generated as a custom prompt. And this prompt is what gets sent to the large language model to retrieve the response. Think of the scenario as a library, where whenever you are typing a question, it is equivalent to asking a librarian the question. The librarian may give you the answer or may tell you, go to this particular book on this particular page, you will find the answer. So that's the same way in which grounding works. It is like accessing a particular information, a particular piece of context in a particular page of information, and then from there, feeding this information back to the user in the format that the user wanted. The second mechanism of working with large language models is called one-shot or few-shot. In this case, you are not really modifying any of the model parameters, but all you are doing is you are showing the large language model one or a few examples of what a good answer looks like. And finally comes the fine-tuning mechanism. Now, the fine-tuning mechanism is the most complex mechanism of interacting with a large language model. Typically, all of the companies or all of the foundational model providers, they have access to each and every parameter in the large language models. Fine-tuning happens when, let's say, you are working with a new area altogether where a group of words has a completely new meaning. For instance, if you are working with the medical data or if you're working with legal data, where a group of words can have a completely new meaning altogether. In these cases, you really need a good tens and thousands of samples of annotated data. Annotated data means examples of sample questions and answers. And that's what you need to feed in order to make the existing large language models better and for it to understand the context in the words that you will be asking going forward. Now, there are two mechanisms in order to do this fine-tuning in a reasonable mechanism, and that is called low-rank adaptation and quantized low-rank adaptation. Think of these two mechanisms as taking the huge large language models, which let's say maybe 65 gigabyte of storage space. A low-rank adaptation takes this 65 gigabyte model and converts it into 3 gigabyte of storage space. And in this 3 gigabyte of storage space, now if you apply these tens and thousands of questions and answers, the system is very easily able to retrieve the group of words and what you are intending to be asking going forward. So now the low rank adaptation can actually get fine-tuned very quickly on just one GPU hardware in the cloud. But fine-tuning should be the last resort. That should not be something that we start with. The first and the second way of working with a large language model should always be grounding and one-shot or few-shot mechanisms. Now, let's take a look at a typical journey of a generative AI product. Now, of course, it doesn't happen, overnight. And also that large language models are constantly progressing and constantly improving over time. There are some considerations that you need to, keep in mind in order to make sure that if you are building a generative AI product, it has adoption, it has the accuracy, and it constantly evolves and gets better over time. So at the initial phase, at the start, you really need to understand what is the return over investment. So if you sit down and invest a day into generating these automation reports, is this really helping your task? If the answer is yes, then of course it is worthwhile. Now, there is a dual steam velocity setup that has to happen. That means if you are generating a generative AI product, you have to operate in two very parallel approaches. The first approach is research and development, where you are constantly, challenging the foundational models. You are constantly working with the updated version of the large language models, and you are constantly taking some of the features and putting them into production. So there is a production unit, and then there is a research and development unit. In the research and development unit, there are three different aspects you need to be considering. First of all, you need to understand what is prompt engineering. So prompt engineering is the mechanism in which language can be structured in a particular format and then sent to a large language model in order to get the desired responses for our questions. Then there are UI UX considerations. The front end or the way in which the responses are returned back to the users are very different from typical and traditional chatbots. Primarily, you have to now give a thumbs up and thumbs down. And this gives the reinforcement learning human feedback in order to constantly evolve and improve a large language model. So the infrastructure or the LLMOps setup is extremely crucial. For instance, like I mentioned, LangChain, along with the grounding, there is an infrastructure setup that needs to happen in order to generate these customized prompts per question that you write. So these three are the considerations in the MVP phase. Now, in the MVP phase, once you have a minimum viable product, what you want to do is make sure the responses for a particular category of questions are always reliable and accurate. And finally, there is this concept of evolution, in which you take the thumbs up and the thumbs down, together, and then you evolve the large language model so that it can do complex reasoning better over time. So let's say that you go to OpenAI's ChatGPT-4 today and you ask a question such that, how is the dollar doing in the market today, and will it stay stable for future? Now, typically chatbots cannot give you predictive responses unless you have furnished the data for it to make these kind of judgment calls. So in this case, if you want such a system to automatically be able to go to the web, gauge some of the economic situations, and make an estimate out of itself, that should be something that it would need to be fine-tuned or evolved for using the reinforcement learning human feedback. So if the user doesn't like a response and it gives it a thumbs down, then those questions are recorded and used to retrain the model so that the next time around, if the user comes and asks the same question, now you have a better format at the responses. In the next session, we are going to be learning all you need to understand about generating the minimum viable product or the prototyping stage of a generative AI product. Before we go, I wanted to share some new updates from the field of generative AI that are super exciting. First off is OpenAI's ChatGPT is now capable of audio and conversational AI. So if you ask a question just through your voice automatically gets transcribed, and that question gets asked, and the response that you get is also voice enabled. Look here.
We want to hear a bedtime story. Tell us a story about the super duper sunflower hedgehog named Larry. Start with telling us a little bit about him. Larry was a unique hedgehog unlike any other. He had bright sunflower petals instead of spines.
And finally, Microsoft's Bing is now chat enabled. That means if you have Bing as your web browser, you can literally start having conversations with ChatGPT-4. I had some very interesting mathematical conversations with them. What I really found is if you ask a question regarding general mathematics, the system is able to respond to you pretty well. But if you ask a domain-specific question, such as if you ask a financial question, then the system says that we cannot give you an answer. So there is a filter around the ethical constraints, which is domain-specific. Let's take a look. So this is the Bing screen. So earlier you would be able to do some searches, images, videos, everything. But now you see there is a chat option enabled, and this chat is your ChatGPT-4. So it is a very strong, large language model where you can enter up to 2,000 words for the system to understand at one time. Now, the interesting fact was I started asking some mathematical questions. So I asked, my stock price is 33,000. It should go up next month by 2.4%. What will be my stock price next month? And here it says, I'm sorry, I'm not authorized to give financial advice. So automatically it zooms in not to the math, but to the domain, and it raises ethical concerns, and it cannot give you a prediction. Now, next I asked, my rent is 3,300. It should go up by 2.4% next month. The same math as before. What will be my rent next month? And again, it says, I'm sorry, I'm not authorized to provide you financial advice. Go to some of the other links and so on and so forth. But now I actually went down and broke down the problem like a math problem. What is 2.4% increase to 330? And now it's able to understand what exactly you asked. It gave you the workup for it, and finally it gives you the answer as 337.92, which is the right answer. So what I wanted to show you is the way large language models are now getting fine-tuned is to first filter for domain. If it's a domain which is more financial or predictive in nature, then it steers clear and does not answer you those questions. However, if it is pure mathematics and simple mathematics, it is able to do such problems. I hope this was interesting. See you next time.